So today we're going to go ahead and go on to lesson number 26. We're going to go and transform or start transforming functions. Our goal is to transform it for any of the given parent functions that we're going to see here using our beautiful parameter K. So this is the first parameter that is going to be exposed to you guys. You already have been transforming linear functions, believe it or not, since you guys were in, I think, Algebra 1, probably pre-algebra, when you guys started graphing lines. You guys were not given the formal my goodness gracious vocabulary of what these beautiful parameters are called. The first one that like I said, is going to be called parameter K. Ready? Listos? Okay. All right. Now, we've been using our functions. We had been saying that we have an input and an output. Our output, we're used to seeing it as y. We're now going to see it in form of f of x because we're going to be seeing functions. So remember that we're going to have a function. Whenever we're given that value, we have to input it into our function and we have to get a beautiful output. If we're given a second value, guess what? We're going to go ahead and do the same idea. So we have our domain and our beautiful range. Now we had our parent functions. We did our beautiful posters. You guys know what they look like now. So if you're given a parent function, all you have to do is look at your variable, and then from there you can determine which of the parent function it is transforming. So, perfect. So parameter, go ahead and copy this one down, guys. Parameter is a number that transforms a function into another function. Parameter is a function that transforms into another function. A number that transforms a function into another function. A parameter is a number that transforms a function into another function. So whenever I talk about parameters, I'm looking for a value in the parent function that is going to transform it into a new different function. ¿Listos? Go ahead. So parameters. You've been seeing parameters for quite some time. You have not been introduced to it as a parameter. So you have been practicing on how to do parameters. Ready? Everybody has this? Beautiful. Okay. All right, so we have our function notation. We're going to go ahead and see our beautiful y's, like I said, in f of x form. And we're going to have our beautiful tables. So I want you guys to copy this one down on your first graph or on your notes somewhere. I gave you guys a copy of a graph or graphing paper. You guys are more than welcome to cut these out. And I've had students paste them on their notes if they don't want the big paper to be like just somewhere in their notes. If you guys like to cut it out and then use it as a little block so you guys can have the graphing paper. Okay. Again, you guys are more than welcome to cut this out and use this. Or you guys can write your notes on this particular sheet and then just fold it and then glue it or staple it onto your notes. I have a space for you guys to write your lesson number. So the first function that we're going to go ahead and look at is our basic function. It's our what type of function? What function is this one? F of x equals what? What is it called? What is it called? It's not a radical. Linear. So therefore, since it's that linear, what does it look like? A beautiful line. So let's go ahead and grab the domain, or let's go ahead and write the domain down in our notes. -2. What is my f of x? Guys, what is my f of x? -2. At -1 is going to be -1. At 0 is going to be 0. At 1 it's going to be 1. And 2 it's going to be beautiful 2. It's just basically reflecting the same x value to the y value. Tito.
I guess copy this down.
We'll fix it right now.
The name of the function is on.
So this one's a linear function. Okay. So now we're going to go ahead and experience what happens when we add 1 to our beautiful x. This is called a beautiful parameter K. And the way that this one's structured is that it is directly outside of our beautiful X value. And we're gonna go ahead and see it as a beautiful constant. Now, the way that it's seen or it's noted inside the function, it looks like this. We have our f of x, whatever our beautiful parent function is, we're adding or subtracting a constant. So if we're adding or subtracting a constant, that is your parameter K. And we're gonna go ahead and note what happens whenever we apply the parameter K. Yeah. Parameter K. We're gonna see what happens with our beautiful function. Go ahead. Everybody has this? No? Okay. F of x plus k, or parameter K, is a parameter. You're gonna go and usually see it as a constant, and it's adding or subtracting to the x variable. For example, f of x plus 5, whatever your parent function is, mother. I said you can write it either or. So if you guys want to keep it on your graphing paper, you guys can keep it on your graphing paper and then just staple it and glue it onto your notes. If you guys don't want to carry the paper around in your notebook, you guys can cut we're going to need the squares for the graphs. You guys can cut them out. And I have scissors and glue sticks. I'll go ahead and take them out right now. Yeah? Yeah? Everybody has this? You guys can use it there, or you can write it in your notes. And I give you guys, yeah. Okay. A ver. Ready. Listos. All right, here we go with our first parent function. Everybody have that? No yet? Okay. Let's see. Here goes our first example. This is what I was asking you guys to have your. We're going to use this graph for this beautiful part. You already have your table there. Let me go ahead. Yes. Okay, so here goes my beautiful table. We already have this one copied down. -2, -1, 0, 1, and 2. Let me go ahead and graph this one, guys. So let's go ahead and graph it first. Here is 0, 0. 1 is 1. 2 is 2. -1, -2. If I were to continue it, we said it was going to extend all throughout my beautiful graph. So I'm going to go ahead and continue to graph all the points. All I'm doing is graphing my beautiful parent function. Here it is. Woo, it looks like this. Qué bonito. Let me make it bigger so you guys can see it. Yeah. All the way through. It is a beautiful graph. I have it in green. All right. So we're going to go ahead and apply the first transformation. And this is parameter K. And we said that whenever we had parameter K, it is a constant that is adding or subtracting to our beautiful parent function. Or it's adding and subtracting to the function that we were previously given. In this case, we are just transforming the first parent function. So what is happening here? We are adding what? 5. So whatever f of x values I have, I am going to add 5. So in this case, I have -2. I'm going to add 5, which is 3. I have -1. I'm going to add 5, which is 4. I have 0 plus 5, and I have 5. The next one, we have 1, add 5, we have 6. The next one is 2 plus 5, and I have 7. So let's go ahead and graph this function now. At -2, I should have at 3. Yes. -1, I should have it at 4. At 0, I should have it at 5. At 1, I should have it at 6. At 2, I should have it at 7. Let's go ahead and predict if I had 3 there, what would happen? 8, so the next one, 9, 10, and so on and so forth. So if I were to go the other way around on my beautiful negative side, I would go down 1. There you go. We have our beautiful parameter. All right, so let's go ahead and graph this one. Very beautiful. Now, in order for me to write this beautiful equation, what happened to my beautiful parameter here? My f of x over here, it was f of x equals x. How do we write this one? Well, I have f of x, and whatever is happening to it, we're going to add 5. So therefore, my f of x is going to be x plus 5. So what happened to this beautiful graph? Here are my matching points. Here's my first point. Here's my point now. Here's my next point. Here's my next point now. My origin, here's this point now. This point, my point here. This point here. This point, and this point here, and so on and so forth. Okay. Now, let's go ahead and do another transformation. Nick Shay, you're going to lose this. Here you go. Next table. Let's go ahead and try this one now. F of x minus 2. By looking at the first graph, what do you guys predict is going to happen to this one? It's going to go down, right? How do we know? We have a -2. So let me go ahead and graph my points. Let's see. This time I'm using the f of x values, not the previous values, the f of x values. So I have -2 and I'm subtracting 2, which is -4. -1 minus 2 I have now. -3, -2, -2, 1 minus 2. And I have 2 minus 2, 0. So let's go ahead and graph these points. At -2, it is -4. At -1, it is now -3. At 0, it's -2. At 1, it's -1. At 2, it's 0. It's okay. No, it's because you guys are gonna analyze what's happening. We haven't digested what we just went through. That's why. Like as in, thought about it. Let's think about it now. Let's see. Let's make an observation. No que slipan ni que nada. Yep. There you go. Beautiful. Now, my next step is to write my new function. It was f of x. What happened this time? I was subtracting 2. So what is my function now? X is going to be minus what? -2. So I'm writing my new function. So this can be basically another function. So I can say h of x equals x minus 2. This one over here can be g of x, my new function, and it's going to be x plus 5. And this is my OG function, basically the original one that I was given. What's the transformation that happened here? And analyze it and then graph it. So see what parameter is given and see what happened to the parameter, what transformation happened. So put your pencils down, guys. So let's see if we can now analyze what's going on. I'm gonna go ahead and highlight one of the points. I need you guys to listen, please. Shh. Now, let's go ahead and do 0, 0. This point right here. Whenever I added 5, what happened to the point afterwards? It went how many steps? 1, 2, 3, 4, 5. Did the same happen to every single point that I had in my original function? Let's go ahead and try it out. Whenever I was at -2, is right here, -2. What happened to it? Did I add 5? 1, 2, 3, 4, 5. So I added 5. What about to -1? 1, 2, 3, 4, 5. So that means that everything on that beautiful line, all I did was go what? How many steps? What direction? Up. So go ahead and make that note. 5 up. I added 5. So therefore, up 5 steps or 5 units. Now, what happened to the next one? Let me go and highlight it. My original right here. This one's my original. What did I do? Subtracted. So how many steps did it go down? 1, 2. In what direction? Up, down, left, or right? It went down. So let's go ahead and say down 2 units. So what does this parameter k do? It transforms my function, whatever is given to me. Right now, we're just analyzing the parent function of x. And I added 5, I added a constant of 5, it moved my function 5 units up. If I subtracted 2, I moved my units 2 units down. Let's go ahead and make a prediction. What do you think what happened if I added 100 units or 100 to my beautiful function? What would happen? It would go 100 units up. If I were to subtract 100 units or 100 values, it would go 100 units down. Go ahead. So let's go ahead and see if it's true for the next one. One more, and then I'll give you guys your guys' beautiful practice. Go ahead and try this one. We're doing the next parent function, f of x equals x squared. Use the next one. F of x equals x squared. So again, my parameter k does what? Up and down. What does my parameter k do? Up, down. Up, down, down. Okay, so what are my beautiful values here? This time we have a quadratic. How do I know I have a quadratic? Look at my beautiful power. It's the power of what? 2. So my parent function here is x squared. What are my f of x values? You guys have this in your beautiful table that I made you guys copy down. 4, 1, 0, 1, and 4. Okay, so let's go ahead and graph this parent function. At 0, 0. At 1, it's 1. At 2, it's 4. At -1, it's 1. At 2, it's 4. And if I were to continue to go, let's see, 3, it would be 9. And at -3, it would be +9. Okay, so this one looks like this. Woo! Mira qué bonito. Beautiful. Okay, all we did was graph the beautiful parent function that we did last week. That's why I have you guys study. Yeah, I made you guys do like a little practice quizzes so you guys can practice and identify. And I even have them here so you guys can look. Aquí están.
They're gonna stay up there?
Yeah.
Can I sit over there?
It's gracious. Alright, that's why we have them up so you guys can see the tables. You guys decided to make them so small, you guys can make it bigger. Okay, so my next transformation, let's see if we can transform this new function, f of x plus 4. Go ahead and tell your neighbors what prediction is this one going to do. Is it going to move up, down? How many units? Make a prediction, guys. I'm looking at Nick Shea. You're grouped. Go ahead and tell them. Everybody here. What's the prediction, guys? What's going to happen to my beautiful graph? Let's go ahead and write my beautiful new function. This time my units are what? Plus what? Plus 4. So let's see, my first one is 4 plus 4, which is 8. How do I get that value? Again, we have f of x values. Plus 4, 8. The next one is 1 plus 4, which is 5. The next one is 0 plus 4. 4. The next one is 5. And the last one is 8. So let's go ahead and see if it's true. Did my graph move up how many spaces? 4 spaces. So let's go ahead and see my beautiful original. Let's go ahead and do 0, 0. It moved up 4. It's right here now. And then to my beautiful right, I have 1. It went now to 5. And my 2, it went now to beautiful 8. And then on my left side, I go up 1. There you go. And then negative 2, it is now at positive 8. Again, I'm trying to draw the parabola as beautiful as I can. So again, did it go 4 spaces up? Yes, it did. So here's my original point. It now goes 4 spaces up. Now, in order for me to write my function, this is how I write my function. I have f of x. Let me go ahead and find this. F of x plus 4 equals, what is my parent function or the function that I'm using here? X squared plus 4. So therefore, this one's going to be g of x equals x squared plus 4. So that's my new function that I'm going to use. Go ahead and come here. All right, try the next one on your own. Let's see if you guys got this, and I'll be walking around to help you guys out. F of x minus 3. So make a prediction. What's going to happen to my graph? What is going to happen to my values? What should happen and what should my graph look like on the other side, okay? And also write your new function. What would happen to my new parent function? Whenever we're subtracting 3 or we're shifting it down 3, here is the original function in pink. Let me go ahead and do this one in blue so you guys can see it. It should go down how many steps? 1, 2, and 3. So this point at 0, 0, it should now be at negative 3. So that's how we're going to go ahead and check. We're going to check our table and then we're going to check our graph. Now, how did we get negative 3? This value right here is going to subtract my f of x values. Where are my f of x? Right here. They're the y values on my first graph. So therefore, I have to grab that 0, subtract 3, and I get that negative 3. Now, my f of x here in this case for negative 2, it's what? Positive 4 minus 3, I should get negative 1. The next value, it's 1 minus 3. It should be what? Negative 2. So again, every single point that we have here, we shifted down 3 units. 1, 2, 3. That's how we double check. 1, 2, 3. This one? 1, 2, 3. 1, 2, 3. We can even grab this one. 1, 2, 3. 1, 2, 3. And we can continue to graph forever and ever. Beautiful. Yeah. So again, what are my points doing? They are shifting up and down. So what's my next point? At 1, it's supposed to be at -2, and at beautiful, let's see, 2. We should have them also at -1. Three, four, five. +1. Put it at right one, -1 for it. It's +1, guys. Sorry, +1. There you go. +1. So that's how you double check your beautiful work. Okay?
Are we done?
Only two examples.
Can we?
All right, I'm gonna go ahead and let you guys practice. Take out your beautiful Chromebooks, guys. Again, I'll go ahead and give you guys some scissors and some glue sticks right now. Let me go ahead and take them out so you guys can cut them and paste them onto your beautiful notebook. Let me save an image.